Hi, this lesson is about systems of equations and how to solve them graphically. In particular, we're going to look at nonlinear systems, which are systems that have parabolas. They could be other things, but we're just going to analyze parabolas. First of all, a system is when I have two equations that I consider together at the same time. The solution for a system are any points where they intersect. That's going to be any place where they have the same x and y value. Now there's two different categories of systems that we're going to deal with. One is when I have a parabola considered together with a line, and I've made an image that shows a parabola and a few different lines, line A, B, and C. You can see that line A intersects the parabola at two places, so there are two solutions for the parabola and A. B only intersects at one place, so there's only one solution, and C is down below the parabola, doesn't touch it at all, so there are no solutions. Those are the three scenarios you can get for a parabola and a line, and that's visually what it can look like. Now the other situation that we need to consider is a parabola taken together with another parabola. There are four situations here, and I've got examples of each graph. In the first case, I could have two parabolas that don't touch each other at all. That could be a situation where one opens up and down like this, or they both open up or both open down, but one's nested inside of the other. You get no solutions. This next one, the parabolas touch at this one point here, so there's one solution. That's called tangent. We say one parabola is tangent to the other. In the third case here, you can see that there are two locations of intersection. And the fourth case is kind of unusual. It's actually a parabola graphed right on top of another parabola, and in that case, every single point is a solution. So there are an infinite number of points or an infinite number of solutions. Now, in this lesson, you're going to primarily use your calculator to graph these functions and find answers. So here are some instructions for how to do that in case you don't remember. What you do is you make each equation a function on your calculator in the y1 or y2 location for graphing. You're going to need to choose a suitable window so that you can actually view the functions and not miss the information. And that's going to sometimes require a little experimentation or thought. And lastly, you're going to use the intersect tool, which is second function button, trace button, and the fifth option. We're going to run through two examples together. So the first one, I've got a parabola and I've got a line. I can tell this is a line because x has a degree 1 and y has a degree 1. Now this is going to need to get rewritten, isolated for y. So I'm going to write it as negative 2x minus 4 so that I can enter it into the calculator as a y equals equation. Now if you get your calculator ready, you may want to pause this and enter these things in your calculator and then try to choose a suitable window, and once you've done that, turn it back on and watch what I've got. Okay, I've graphed the two, and I've got the parabola here and I've got the line here, and it seems to go off the screen a little bit to the bottom. Now this was the zoom 4 window that I used. Zoom option 4. Okay. Now you may want to try zoom 6 to see if you get a little bit better perspective. There's the whole parabola, and there's the line. Now it looks as though it just touches at one place, but sometimes that can be deceiving. There's a way to zoom in and get a closer look. It's called the zoom box. Push the zoom button, and the very first option is a box. We're going to define a box based on two opposite corners of a rectangle. We start with the cursor at 0, 0, and I'm going to push enter and make that my reference point. You can see as I move down to the right, I'm forming a box, and whatever's in this box is what's going to get expanded for us to take a closer look. I'm going to try zooming in on that. So I'm down in the third quadrant. There's part of my parabola. There's the line. Sure enough, it does look like it just touches at one point, which is called tangent. So I'm going to push second function, trace, to get to the intersect menu. I'm going to choose option 5. going to be asked three questions. The first curve, you'll notice up in the corner it says y1 and it has the parabola. That's the first curve I want, so I push enter. The second curve, well, that's the line, exactly, and the cursor's on the line. That's the second graph that I'm interested in. And the third thing I'm asked is for a guess value, to move my cursor toward the place it intersects. You don't have to be accurate here, just move it a couple of times and push enter. Calculator will calculate the place where they cross. Now, the calculator has limitations. The algorithm sometimes does funny things for rounding. This is actually the point -1, -2, and we're going to have to just recognize what's going on. I'm going to just take a screenshot of that, and I'm going to post that into my notes here. And I'll talk about this in a moment here. Here we go. So what this tells us is that my solution is at -1 for x and -2 for y. Now, a solution are the points x, y that satisfy both equations. So if I substitute the x and the y coordinates into both equations, they should make true statements. So if I put -1 here and I put -2 here, this should make a true statement. -1 minus 1, -2, squared is 4. 4 times half is 2. 2 take away 4 is -2, so that works. Likewise down here, substitute -1 for x. This term is 2. 2 take away 4 is -2, and it works. So that is a solution to the system. Let's look at the second one. This is parabola and parabola, and you'll notice that the first parabola is the same, so we don't have to change that. We're just going to add this parabola instead of the line. Again, pause, enter this, choose a window, see if you can figure this out, and then rejoin me. Okay, let's have a look. I already entered it there, so I'm going to turn my line off. I'm going to turn my parabola on. Let's make sure I got that. Yep. And I'm going to try zoom 4. Standard window that often shows me what I need to see. Not bad. I can see that this parabola goes down. I'm missing the vertex, and this parabola opens the other direction with a maximum point, and I've also missed that, but I can see clearly where the intersections are. They're in my graph, so I'm going to go with this window. So I want to find where that point is and where this other point is. I'm going to do second function, trace, intersect. Again, I'll be asked three questions. First curve, y1, yes. Second curve, y3 in my case, yes. And a guess value. Now, I can move the cursor, or I can type a number on the calculator as well. It looks as though it intersects at -2, so I'm going to type in -2 as my guess. And sure enough, the intersection is -2, 0.5. I'm going to take a screenshot of that and add that to my notes here. And I'll go back and get the other one, and I'll fix that in a minute. Okay, my other intersection's over here in quadrant 1. So second function, trace, option 5, first curve, second curve. I'm going to guess, I'm going to try 3. And it's a little further, it's at 4, 0.5. So I'm going to capture that as well, and I'm going to add that into my notes. Okay, so our calculator gave us what we needed, and I don't know where my other one, oh, there's my other one. Whoopsie, having a little trouble here. I think I'll undo that step. There we go. Let me see if I can just get that one image to move across. There we are. And I'll enlarge it a little bit, and I'll enlarge this one a little bit. Sometimes technology is wonderful, sometimes not so much. Okay, there we go. Anyway, that'll do. So I found my intersections to be at 4, 1/2. That's what this one said, and the other one said -2, 1/2. Again, I can substitute these into both equations. They should make true statements. That's the basics of what systems are, recognizing the number of solutions in systems, and how to use your graphing calculator to find the answers.